Okay, so let's talk about sequences and series. First, let's talk about a sequence, and let's look at a definition of a sequence. A sequence is a list of numbers whose domain is the natural numbers. So remember, domain means the input, correct? And natural numbers, you have to remember what the natural numbers start with. What's the very first natural number? Yeah, it's 1, and then 2, and then 3, and then 4, 5, 6, 7, etc. Got it? Okay, so don't think too deep on this. Don't think too deep on this. We are going to go straight into an example, and the examples are asking us to find the first 5 terms of the sequence. And the first sequence they're giving us to work with is a sub n equals 4n minus 1. Now, a sub n, that means that's the nth term of the sequence. And to find the nth term of the sequence, I'm going to take 4, multiply by whatever n is, and then subtract 1. Now it asks me to find the first 5 terms of the sequence, correct? Which means if I want to find a sub 1, which is the first term of the sequence, right? Because that's what that notation is telling us now. The n has been replaced by the 1, so that's the first term. That means on the other side, you're going to do 4, good, I heard you, times 1 minus 1, which means the first term of the sequence is equal to, excellent, 3. How about the second term of the sequence? How do I find it? Yeah, that means 4 times 2 minus 1, which means term number 2 is 7. Are you with me? I know what some of you are thinking. Some of you are going, wait. Is it that easy? And my answer is yes, it's that easy. Don't complicate this. Okay? How about a sub 3, the third term of the sequence? Good. 4 times the 3 minus 1, which means the third term of the sequence is 11. How about the fourth term of the sequence? Yeah, that fourth term of the sequence is going to be 4 times 4 minus 1, which means the fourth term of the sequence is 15. And last but not least, term number 5. Yep, 4 times 5 minus 1, which means term number 5 is 19. Cool? Does this make sense? Okay. How about let's look at another problem. Now don't think too deep, okay? So the nth term of the sequence, and by the way, when I say the nth term of the sequence, that's the generic term. That's the formula for the sequence, basically. Are you with me? It's the formula of the sequence. So this formula is -1 to the power of n times n squared. Okay, so to find the first term here, plug in a 1, which means that's definitely a -1, right? Times 1 squared, which is, good, it's going to be -1, isn't it? Times 1, which is -1, right? Okay, just so I can write it out for people to see. The second term of the sequence, yeah, that's going to be a +1, right? -1 squared, times 2 squared, which is 4, so term number 2 is 4. How about term number 3? Yeah, -1 to the power of 3 is -1. 3 squared, 9, which gives you -9. Term number 4? Yeah, -1 to the power of 4 is +1. 4 squared is 16. That gives me 16. And last but not least, term number 5 is, yep, that's -1 times 25, which is -25. Cool? Yeah, this stuff isn't too bad, so don't go looking too deep for anything hidden. I'll be right back. Okay, now let's talk about a recursive sequence. A recursive sequence is where one term depends on another. For example, if I'm trying to find the fifth term of the sequence, then for me to get the fifth term of the sequence, I actually need to know term number 4. But to get term number 4, I actually need to know term number 3. But to get term number 3, I need term number 2, and to get number 2, I need to know number 1. Are you with me? So every term in this sequence is going to depend upon previous terms. That's different than the first 2 examples we did. The first 2 examples were just like, hey, here's the formula, find me the first 5 terms. So we just plugged in numbers 1 through 5. This one is a little bit different. Okay, so hang in there. So let's still find the first 5 terms of the sequence, and let me get you an example we're going to work with. A sub 1, what does that mean? Good, the first term. So the first term of the sequence is 256. Now, a sub n plus 1 is equal to the square root of a sub n. Notice something. This is an n. This is n plus 1. Doesn't the plus 1 make this higher than a sub n? It does. So now, see if you follow along. I want to find term number 2. Are you with me? The formula says I need to know n. Well, couldn't I rewrite term number 2 as a sub 1 plus 1? Because doesn't 1 plus 1 give me 2? Which means I'm looking at the square root of a sub 1. Because these guys, right, these n's right here are matching up. That's a 1 and then that's a 1. Cool? So let me simplify it then. This means to find term number 2, I need to find the square root of term number 1. Well, don't I know the first term? Yeah, it's 256, which means to find term number 2, I need to find the square root of 256, which is, yep, I know some of you went to your calculators already and got it, 16. Okay, so how about to find term number 3? How am I going to find term number 3? Good, I think I heard some of you say it. I have to find the square root of term number 2. Because that's what this tells me. This is one more than this one is. Which means to find term number 3, I got to take the square root of term number 2. Which means this is going to be the square root of 16, which means term number 3 is equal to 4. Excellent. How about term number 4? Sorry about that. I was getting ahead of myself. Yeah, I need to find the square root of term number 3. Term number 3 is 4. So the fourth term is 2. And the fifth term. Yeah, to find the fifth term, we got to do a sub 5 is equal to the square root of 2, the one before it. Good? Okay. So now, let's look at a second problem. They tell me the first term is equal to 4. And they tell me a sub n plus 1 is equal to 1 plus 1 over a sub n. So notice, this term is one more than the one we're plugging in, right? Okay, don't think too deep. Some of you are going to think too deep. Don't think too deep. I'm going to find term number 2 next. Correct? I can't find term number 3 because this is a recursive sequence. And to find term number 3, I need to know term number 2. So, to find term number 2, I'm going to do, according to the formula, 1 plus 1 over, good, I heard some of you, a sub 1. Because this guy is 1 less than this one that I'm finding. Which means term number 2 is going to be found by doing 1 plus, that's right, 1 over 4. So term number 2 is basically 5 over 4 when you add them together. Correct? Okay, how about term number 3? Formula says 1 plus 1 over, good, a sub 2. Well, a sub 2 is a fraction, isn't it? So I'm doing 1 divided by 5/4. Well, what's 1 divided by 5/4? Yeah, 4/5. Which means when I add these together, we get 9 over 5. Good? Okay. I need a little bit of board space, so bear with me because we have 2 more terms still to find in this recursive sequence. So, a sub 4 is next on my list. So, to find the 4th term, the formula says 1 plus, 1 over a sub 3. Well, a sub 3 is a fraction, so 1 divided by 9/5, which means 1 plus, excellent, 5/9, which means the 4th term is equal to, good, 14 over 9. Okay, we got 1 more to find. A sub 5. Formula says 1 plus 1 over the guy before it, the term before it. So we're doing 1 plus 1 divided by 14/9. A sub 5 equals 1 plus 9 over 14 after you do the division, which means your 5th term is 23 over 14. Cool? Okay. Recursive sequences. Each term depends on the term before it. That's different than the first 2 problems we did. I didn't care what each of the terms was. They didn't depend on each other. A recursive sequence does. And you're like, well, how do I know when I have a recursive sequence? Well, if they give you something that looks like this, especially that formula that has n plus 1 here and n there, I know I got a recursive sequence. Good? Okay, stay tuned. I'll be right back with series. Okay, so let's take a look at 2 very specific types of sequences. One is known as an arithmetic sequence. The other one is known as a geometric sequence. Let's look at arithmetic sequence first. Now, arithmetic almost sounds like the word arithmetic, correct? And in arithmetic, most people think of addition and subtraction. So yes, keep those 2 operations in mind when you're thinking about arithmetic sequences. Now, the definition of an arithmetic sequence says that a sequence is arithmetic if there exists a common difference that is called d, such that, now take a look here, what's a sub 1 represent? Yeah, that's the first term of the sequence, isn't it? And notice, the second term of the sequence is gotten or derived by taking a sub 1, the first term, and adding d, this common difference, right? Okay, and now I go to the third term. Notice, what do you think we did to the second term to get the third term? You're like, well, there's a 2 in front of the d. That's true. And I know 2, most people will think 2 times d. But understand something. Sequences are supposed to have the same thing happening from one term to the next. Either we're adding the same number to get from one term to the next, or you're subtracting the same number, or whatever. So if you notice, what we did here to the first term of the sequence is we added d to get to the second term, didn't we? No, this is not a recursive sequence. This is just us looking at what's going on. Okay, so hang in there. And from the second term to the third term, then, we have to have the same thing happening, which means we had to add d once again. And so let me ask you something. What's positive d plus d? Yeah, that's 2d, correct? And if I wanted the fourth term of the sequence, what do you think you would have to do to get the fourth term of the sequence? Sure, you'd have to add d again. So it would end up being the first term plus 3 times d, because by that point you've added 3 d's. Does that make sense? Okay, now something else I'd like you to be very aware of. This is the third term of the sequence, right? And notice we had 2 D's that were added to get to the third term, correct? This is the fourth term of the sequence, and we added 3 D's to get to that fourth term. So if I want the, I don't know, if I want the 32nd term by this pattern, you know you're going to take a sub 1, and by that point, how many D's would you have added? Hopefully you said 31D, because D did not pop up until term number 2. So D, or the number of D's, is always 1 behind the term I'm talking about. Remember, fourth term, 3 D's. Third term, 2 D's, right? So 32nd term, there would be, 31 D's. If I wanted the 97th term, then it would be a sub 1 plus, there you are, 96 D's, because you would have added 96 of them by the time you get there. So that comes up with the generic formula for an arithmetic sequence. The generic formula says no matter which term you're looking for, you're going to take the first term and add D, right, times n minus 1. Again, if it was 32, then there's 31, right? 32 minus 1, 31. If it was 97, then it would be 97 minus 1, or 96 in front. Good? Okay, let's look at a geometric sequence. Now, a sequence is geometric if there exists a common ratio. Now, ratio, we're using R for ratio. Ratio is a fancy term also for us using division. Or it could be multiplication, because I could also multiply by the reciprocal of a fraction, right? So arithmetic uses addition and subtraction. Geometric is going to use multiplication and division. So that's the huge distinction between the two. But they act almost the same. So let's keep reading. In this case, we have a common ratio, and it's called R. So notice the pattern. A sub 1 is the first term. To get to the second term, I'm doing a sub 1. We had to multiply by R to get the second one. And to get from the second to the third, you're like, there's an R squared. So what do you think we did to get from the second to the third? Good. You're like, well, if you multiply by R here, then you're going to have to multiply by R there to get to that third term. Absolutely correct. And the fourth term, and the fifth, etc., right? So notice, this is the fourth term right here. Do you notice R is to what power? The third power. Again, R is 1 behind the term I'm on, because R didn't pop up until term number 2. So the generic formula for a geometric sequence, no matter which term you're looking for, you're going to take the first term and multiply it by R to the n minus 1. So for example, if I want the 43rd term, you're going to take a sub 1 times R to the, good, I heard you, 42nd power, right? N minus 1, 43 minus 1, 42. R popped up on term number 2, so it's always going to be 1 behind. And if I wanted R, let's say to the 19th, or pardon me, a sub 19, which means the 19th term, then I would take the first term and multiply it by R to the, I heard you, 18th power, 1 behind. Good? Remember, these n's represent the term you're on. Is it the 43rd term? Is it the 32nd term? Is it the 97th term of the sequence? Is it the 19th term of the sequence? And whichever term we're on tells me what the D is going to get multiplied by, or what power the R is going to be to. Cool? Okay, so hang in there. I've got some examples of these sequences for us. Okay, so let's look at these directions. They're asking us to find a sub 1, which is term number 1, and either D, the common difference, or R, the common ratio. So basically what they're asking us to do is to determine what kind of sequence I have. Because depending on what kind of sequence I have will tell me if I'm finding the common difference or the common ratio. Cool? Okay, so let's take a look at the first problem. Now, some of you may be able to tell right away if this is an arithmetic or geometric sequence, and I get that. But for those of you who are not certain how to tell, here's how we're going to handle this. So, if this is an arithmetic sequence, I'm going to call it AS for short, then if I take the first term and add, and you know what, I'm going to write it this way. So hold on, I'm going to do a little bit of notation for us based upon the definitions. If I take the first term and add that common difference, I should get the second term, shouldn't I? Which in this case would be the first term is 3. I don't know what the common difference is yet, and it should be the second term, correct? Which means the common difference here would be a positive 5, wouldn't it? If it was an arithmetic sequence, agreed? If this was a geometric sequence, then by the difference of a geometric sequence, if I took the first term and multiplied it by r, the common ratio, that would get me the second term, wouldn't it? So, again, the first term is 3. I don't know what the r is, and it would equal the second term, which is 8. Which means my r would be this fraction 8/3. Agreed? Now, here's the deal. We're going to see which one of these actually fits with this sequence. I know if I take 3 and add 5, I get 8. The question is, when I look at the second term 8, if I add the 5 to it, do I get the third term? I certainly do. And if I take the third term and add this common difference, do I get the fourth term? Absolutely, I do. Is that going to work if I multiply by 8/3? If I take the 8 and multiply by 8/3, will I get this third term of 13? Yeah, no. This particular sequence is an arithmetic sequence. Its first term is 3, and in this case, since it's arithmetic, it has a common difference of a positive 5. Cool? Okay, let's look over here to problem number 2. Again, I've got to figure out if this is an arithmetic or a geometric sequence. Some of you can tell right away, some of you are not certain, so here's the deal. Same thing. If this is supposed to be an arithmetic sequence, then when I take term number 1 and add the common difference, I'm supposed to get term number 2, correct? Well, term number 1 is 2. I don't know what the common difference is yet, but the second term is a negative 10. So when I solve for D, what do I get? Yeah, I get negative 12. Okay. Now, if this is supposed to be a geometric sequence, then if I take term number 1 and multiply by the common ratio, I get term number 2, don't I? Well, term number 1 is 2. I don't know what the r is yet, and it should equal negative 10, the second term. When I solve for r, I get the common ratio would be a negative 5, wouldn't I? Okay, so now let's decide which one of these works for this sequence. The first term, if I add negative 12, I get the second term of negative 10, correct? If I take the second term of negative 10 and add negative 12, do I get positive 50? Yeah, no, that's not working very well. How about over here? I take the first term of 2, multiply by the common ratio of negative 5, do I get negative 10? Yes, I do. If I take the second term of negative 10 and multiply by negative 5, do I get the third term of 50? Yeah, I do. This one is a geometric sequence. And the first term of this geometric sequence is 2, and its common ratio is negative 5. Cool? Hang in there. I got a couple more of these problems for us. Okay, so let's look at these two problems. Now, I know some of you are thinking, hey, you know, those last two problems were easy. Did I really need to do all that work? Of course not. Some of those sequences are very obvious if they're arithmetic or geometric. And some of them are not so obvious. So, let's take a look at problem number 3. They're still asking us for the first term and either the common difference or the common ratio. So here's the deal. On this one, I think it's pretty important to be able to identify whether it's arithmetic or geometric by using the same method I showed you on the first two problems. So again, if it's arithmetic, that means I take the first term, add that common difference, and it should give me the second term, right? Well, the first term is 2. I don't know what the common difference is yet, but it should equal the second term of 2 root 3. Which means d equals 2 times the square root of 3 minus 2. Yeah, that one's kind of interesting looking on the common difference. I'm sure hoping that's not it. Okay, let's see if it's geometric. So again, first term, but for geometric you're going to multiply by that common ratio, and it should give you term number 2. So first term is 2, don't know the common ratio, and the second term is 2 square root of 3. When I solve for r, I divide both sides by 2, I just get the common ratio of square root of 3. Alright, so let's look. I know if I take the first term and add this to it, I get the second term because that's what we used. But if I take the second term and add 2 square root of 3 minus 2, what do we get here? Yeah, these guys can be added together because they're the same, so I get 4 square root of 3 minus 2. And those can't be added, right? Well, that certainly isn't 6, so that's not looking so good. Let's look at this one. I know if I take 2 and multiply by 2 square root of 3, of course I get the second term. If I take the second term and multiply by the common ratio, let's see what we get. Well, we get 2 times the square root of 9. What's the square root of 9? 3, so we get 2 times 3, which is 6, right? Which is the third term, isn't it? So, looks like this is a geometric sequence. Looks like term number 1 is 2, and the common ratio is square root of 3. Cool? Okay, let's look at number 4. Got to figure out if it's arithmetic or geometric. So, again, if I take the first term, add the common difference, I should get the second term. So 3 halves plus d needs to equal 9 over 4. So to get the d, you're going to subtract 3 halves from both sides, aren't you? Which means you need to have a common denominator in order to do the subtraction, so the common difference would be 3 over 4, wouldn't it? Okay, let's look at geometric. Let's see what this would look like. I take the first term, multiply by the common ratio, and that should give me term number 2. Well, first term is 3 over 2. Multiplied by r should give me 9 over 4, correct? To find r, I have to multiply both sides by 2 over 3, the reciprocal, don't I? So let's see. That's twice. That's 3. That looks like my common ratio is 3 halves. So let's see which one it is. I already know that it works between terms 1 and 2. If I take the 9/4, the second term, and add 3/4 to it, I'm hoping I get the third term. So what do we get? 12 over 4? 3. Ooh, this works. And I could do it again. I could take the 12/4 and add 3/4. I get 15, right? I'm thinking it's arithmetic, but we're going to check the geometric just to make sure. If I take the second term of 9 over 4 and multiply by 3 over 2, what do we get? 27 over 8. Is that 3? Nope, it certainly is not. So this one is definitely an arithmetic sequence. And in this one, my common difference is 3/4, and my first term is 3 over 2. Got it? Cool. Got another one of these. Hang. Okay, so let's look at this problem. This problem actually is asking you to find a sub 1 and d. Since they said find d, then you know this is going to be what kind of sequence. Yeah, you know it's going to be arithmetic, so you don't have to figure it out. You know it's arithmetic. And sometimes with these particular problems, you're going to have to know if it's arithmetic or geometric to start with, because this could go either way. So, since it's arithmetic, they've given me the 17th term and they gave me the 28th term, didn't they? Okay, so let's think about this a second, all right? Generically speaking, how do I find term number 17? What do I do based upon that definition? Yeah, I'm going to take the first term and add what? Good. Remember, the D, the common difference, didn't start on term number 1. It started on term number 2, which means the D is always one behind, isn't it? Which means to find term number 17, you're going to add 16 times D, right? Okay. And to find the 28th term, you're going to take the first term and add, good, 27D. You're like, why are you asking for this? Now let's think about it. They're asking you to find two variables. Well, if they want two variables, that means you need to have, yeah, two equations, right? That's the MO, so to speak, in math. You're solving for two variables, you need two equations. You're solving for three variables, you need three equations, and so forth and so on, right? Okay, so these two generic equations I used because they gave me the 17th and the 28th term. And now, check this out. I know a sub 17. What is it? Yeah, it's negative 40 equals a sub 1 plus 16d. There's one equation with two variables, isn't there? Over here, I know a sub 28. This is negative 73 equals a sub 1 plus 27d. Here's a second equation with the two exact same variables as in the first equation, right? Okay, and now it's your choice to use substitution or elimination. Me personally, I'm going to use the elimination method. I'm going to cancel out the a sub 1's because that's going to be the easier of the two variables to get rid of, which means I'm going to multiply one of these equations by a negative 1. And it doesn't really matter which one I multiply by a negative 1, okay? So, I think I am going to multiply this equation by negative 1, which means this is a positive 40 equaling a negative a sub 1 minus 16d, right? And then I have a negative 73 equals a positive a sub 1 plus 27d. Agreed? Okay, so you have negative 73 plus 40. What is that? Yeah, that's like negative 33, isn't it? These a sub 1's drop out, right? And what do you get here? Yeah, you get a positive 11d, don't you? Right? And so now you know d. d equals a negative 3. Excellent. Well, now that you found d, couldn't you plug it into one of these equations to find the a sub 1? Yeah, you can. So, I'm going to take it and I'm just going to plug it into this one. Why? The numbers are smaller, no other reason. So, this found d. So, to find a sub 1, I'm going to take negative 40 equals a sub 1 plus 16 times negative 3. That's what we said the d was. Which means negative 40 equals a sub 1 minus 48. Add that 48 to both sides, I get a sub 1 is equal to 8. Yes? So I found what they were looking for. They asked me to find a sub 1. So I did. A sub 1 is 8. They asked me to find d, which was negative 3. I could find any other term I wanted for this arithmetic sequence knowing those two pieces of information. Hang in there. I'm going to show you how we're going to do that. Okay, so let's go back to problem number 1 and problem number 3. In problem number 1, we determined it was an arithmetic sequence with the first term being 3 and the common difference being 5. And now they're asking us, find a sub 10. They now want us to find the 10th term of this arithmetic sequence given this information. So, check it out. In an arithmetic sequence, how do you find the 10th term? Generically. Good, you take the first term and you add, because it's arithmetic. Yeah, 9 times d, because the d's are one behind, right? Okay. Well then, they gave me the first term and they gave me D. So to find term number 10, I'm going to take the first term of 3, add 9 times 5, because that's my common difference. So term number 10 for this arithmetic sequence would be equal to 48. That's cool. Knowing the first term and the common difference, I could find any term in this arithmetic sequence as long as I have these two pieces of information and I know how to find each term generically speaking. Because then all I got to do is plug in the numbers, right? Okay, let's take a look at this one. This one, which was problem number 3, we found the first term of 2 and we found the common ratio was the square root of 3. And in this one, they're asking us to find a sub 9, term number 9. Well, for geometric sequence, generically speaking, you find term number 9 by, good, taking the first term, multiplying it by the common ratio to the power of 8. Again, that's one behind, isn't it? Okay, so term number 9 is going to be found by us taking 2 and then the square root of 3 to the power of 8. And I know some of you are on your calculators and you're already working that out, and I have this as 81. And some of you are like, how'd you come up with that so quickly? Well, here's the deal. I have 8 of those, don't I? So think about it. If I take square root of 3 times itself, isn't this just a 3? So if I pair these up, I get just a 3, right? Well, if I have 8 of them, I have 4 pairs. So I basically have 3 to the power of 4, which is 81, isn't it? Yeah. Try to exercise this a little bit more. Okay. Anyway, term number 9 for this geometric sequence is 162. Cool? Okay, hang in there. I'm going to show you how to sum these sequences without literally writing all the sequences down that you need and adding them